All right, we're back. We are on page 66 now. We just did a bunch of stuff with compositions, and we're going to do more with compositions, but these are going to be a little different. So one thing that you may have noticed, you also may not have noticed, you may have noticed that every composition that we've done previous to this page has ended on a regular trig function. Like the final thing we did was find the tangent of something, the sine of something, the cosine of something, whatever, normal trig functions. On this page, they're ending with inverse trig functions, which is kind of weird because inverse trig function, the inverse trig of something is an angle. The answers to these are going to be angles. They're not going to be ratios. Every previous problem that we did pretty much, certainly with the drawing triangle stuff, ended with a ratio as our final answer. Here we're going to get an angle as our final answer. So let's see if we can do it. So it's going to be a little weird at first, but it's not that bad. Here's what I think when I see this problem. I want to find the cosine inverse, the inverse cosine, the arc cosine of the sine of 3 pi over 5. Well, if I have the inverse cosine of the cosine of an angle, I have a prayer. If I have the inverse cosine of the sine of an angle, I have no idea, right? I don't know how to connect those. But I know that the sine of x is equal to the cosine of pi over 2 minus x by cofunctions. So I can use a cofunction identity to change sine of 3 pi over 5 into cosine of something. So I'm going to do that. Let's see. So this is equivalent to the cosine inverse of the cosine of pi over 2 minus 3 pi over 5. So there's like a lot of annoying arithmetic that you have to do on these problems. And if you haven't picked up on it, I'm not like a huge fan of doing arithmetic. So 5 pi minus 6 pi is negative pi over 10. Okay, now I kind of know what to do. So I have two options, I think. One option is, well, I have like 1,000 options actually. Cosine of negative pi over 10. I could just kind of like think about it. So I could think it's inverse cosine. So I'm trying to do this. This is the part of the unit circle I'm allowed. Negative pi over 10 is not there, right? Negative pi over 10 is here. But I know that cosine is positive in the first and the fourth quadrant. I'm in the fourth quadrant. So I want the angle that's between 0 and pi that has the same cosine, the same x coordinate as the angle through negative pi over 10. It's going to be this. It's actually just going to be pi over 10. So using this picture, I was able to find this without an issue, right? So using that idea, I get pi over 10. Alternatively, because cosine is an even function, so let me just explain briefly again why it was that the answer is not negative pi over 10. Once you get to this point, right, you have the cosine inverse of the cosine. So now the question becomes, is the angle that you're dealing with going to be in the range of inverse cosine? Because if it's in the range of inverse cosine, it's the answer. If it's not in the range of inverse cosine, more work needs to be done. You need to find the angle that is in the range, so between 0 and pi, that has the same cosine as this angle. So that's what we ended up doing because we had to look and see where they have the same x coordinate because it's cosine. So that we were able to do. So that's why we did the extra work. Another thing you could have done, because cosine is even, you could say that the cosine of negative pi over 10 is the same as the cosine of pi over 10. And then pi over 10 is in the range of inverse cosine. So that's your answer. That's an alternative way of doing it. Let's try another one. I feel like they really just benefit from like a lot of attempts basically. So here, not the same function. So I'm going to cofunction my way to it. And the reason I can do that is that the cosine of x is equal to the sine of pi over 2 minus x. So this is almost always your first step if you have like different trig functions. It only really works though if you have cofunctions, right? If this was the inverse sine of the tangent of something, like who knows? Good luck on that. But this one we can do. So it's going to be the sine of pi over 2 minus 6 pi over 7, which is the sine inverse of the sine of, so it's 7 pi minus 12 pi is negative 5 pi over 14. Okay, so the question you have to ask yourself is, we've gotten to the point, I'm trying to make this consistent. So we got to the point where we have the sine inverse of the sine. So if the angle that we're dealing with is in the range of inverse sine, it's the answer. If it's not in the range, then we have to think like, well, what what angle in the range is going to have the same sign. So it would have the same y value. But this, if we do our picture, -5 pi, so think about in 14ths, negative pi over 2 would be -7 pi over 14. And pi over 2 would be 7 pi over 14. And -5 pi over 14 is definitely in there, right? It's like kind of here-ish. So this actually is the answer. So we don't have to do any additional work because -5 pi over 14 is already in the range. It already worked. So we were good. I'm going to try another one. So this, we're going to cofunction. So these, I like these problems because they're just like, you're just playing around. You're trying to like solidify some of the things you know, use some of the information that you know, draw some more pictures, all that good stuff. Do stupid arithmetic. Cosine of, all right, so I get, I only need 11. I get 11 pi minus 29 is -18 pi over 22. All right, so I'm going to use the fact that cosine is even, right? So cosine of x is even. So I'm allowed to say that the cosine of -18 pi over 22 is the same as the cosine of 18 pi over 2, which is going to be, I'm also going to simplify that to 9 over 11. Cosine of 9 pi over 11. So now we've got the cosine inverse of the cosine. So that's good. The question we need to answer is this in the range of inverse cosine? Because if it is, it's the answer. If it's not, then we got to do more work. So here's this. So this would be 0 pi over 11, and this would be 11 pi over 11, because pi, and 9 pi over 11 is definitely in there, which means it is the answer. All right, I'm gonna do one more, and then the other two problems look like they're basically the same, like 4 problems. So I'll do this one, and then we'll check on the calculator and see how it went. And then if it didn't go well, I guess we're gonna try to fix it. So cofunction. Okay. So this will be the sine inverse. It's really nice when they just work out. All right, so this is gonna be like 9, I guess. So what is 23 minus 9 is 14. So -14 pi over 18. 9 and 4, whatever. I think that's right. Okay, so sine is an odd function, but that doesn't exactly help us all that much on this. But what does maybe help us is, let's simplify this. Sine of -7 pi over 9. All right, so we have the same functions, so it's good. We could potentially be done here if -7 pi over 9 is in the domain, in the range rather, of inverse sine, which it is not. So let's draw a picture and figure out why it's not. Here, here, right? So we're doing over 9. So think of it, what's half of 9? 4.5, right? So this is 4.5 pi over 9, and this is -4.5 pi over 9. So -7 pi over 9 is going to be kind of like here. So sine is the y value, so we need the angle with the same y value that's actually in the range. So that's going to be here. So how can we figure that out? Well, think about reference angles, right? So -7 pi over 9, like you're missing 2 pi over 9 to get you here, which means that this angle here will also have a reference angle of 2 pi over 9, but it's going to be -2 pi over 9 because you got to rotate the negative direction. So these, it could take a little bit of thinking. Like you should, I don't know, pause the video, whatever, try to do these again on your own, like thinking your way through it, and see if you get the same answers. But first, let's go to the calculator and see if we get the same answers, because maybe these aren't right. I hope they're right. I mean, that's obviously my goal. Arc cosine of the sine of 3 pi over 5. You've got to be in radians when you, oh God, okay. So what is that? What is pi over 10? All right, I mean, we got it. I don't know what the calculator is doing there, like at all. Oh, actually, I kind of do. There's like, so for weird reasons, you can find the sines and cosines of the pi over 5s, which maybe if we have time, we'll talk about it at some point. I don't know what it means to have time when you're just watching a lot of videos. Like, I mean, obviously you have time, but so we got this, we just got the equivalent answer, and that's kind of interesting. Arc sine of the cosine of 6 pi over 7 gives us negative 5 pi over 14. Got it. Arc cosine of the sine of 29 pi over 22. 9 pi over 11. Got it. Arc sine of the cosine of 23 pi over 18. Negative 2 pi over 9. I'm really impressed that we were getting all these right, because when you're doing these on your own, like, you know, I'm talking my way through it, just thinking about a lot of things. Like, it's not that easy to stay focused, really. So I'm glad that this has worked out. So I'm gonna go back to the notes, come back in the next video, and we're gonna tackle parts E and F and go from there. So the little pictures, really helpful. Keep thinking about what you need. It's all about the range, really, of the inverse functions, and the fact that inverse whatever of a ratio gives you an angle. So angles are the answers here, not about drawing triangles. All right, so I will see you in the next video.